All right, here we go. Section 8.8, solving radical equations, day 1. So our goal here is going to be to solve these equations for x or whatever variable that we're given, and we're going to do that through inverse operations. So we need to think about what's going to undo radicals and exponents and stuff like that. But first, we need to get those things that are underneath the radicals or being raised to powers isolated before we can even worry about how to undo them. So for example, here in example number 1, we have 5 minus the 4th root of x equals 0. So we need to isolate the 4th root of x. We can start by subtracting 5. So now we didn't do anything with that minus sign, so it kind of carries with us for now. Okay, so again, we're trying to isolate the 4th root of x. This is technically a negative 1. So we will divide both sides by negative 1 because it's negative 1 times the 4th root of x. That's kind of what's happening there. That cancels those out. So we have the 4th root of x equals positive 5. And then once you have your specific thing isolated, you're trying to ask yourself, what will undo the 4th root of x? And hopefully you know that that is just the 4th power. We kind of done that with square roots, where we raise the square root to the 2nd power, and it undoes the radical. So now we have to raise it to whatever our index is, which in this case is 4. What you do to one side, you have to do to the other. So the 4th root of x raised to the 4th power leaves you with just x. And the 4th, or 5 to the 4th power is 625. Because your variable is isolated, you are done. That is it. All right, so the next one, we have x to the 4 thirds that's being raised to a power. The 3 is not, so we need to start by dividing both sides by 3. X to the 4 thirds is going to equal 81. Now, we need to get rid of that 4 thirds exponent. We could probably do this in just one step. We can kind of use our power to a power rule. So a little trick for you would be to multiply or raise both sides to the reciprocal exponent, so the 3/4 power. Because when you take 4 thirds, I'll highlight it. Oh my goodness. When you multiply those two, because you're raising power to a power, you multiply the exponents, you get 1, so we just get x to the 1st, or just x. On the other side, though, we have 81 to the 3/4, so we are going to have to clean that up just a little bit. So let's start by rewriting it. So the 4th root of 81 to the 3rd, which again doesn't seem so nice, but we can do, oh my goodness, let's jump up here quick. We can do this, 81, 81, 81, because this exponent of 3 means I have 3 81s. And then you can just break down each one of those individually. So we'll go 9, 9, 3, 3, 3, 3. And each breakdown is going to be the same. Probably should have left myself a little more room. Try to squeeze it in here, though. All right, so then my index is 4, so that means here's my radical. I'm looking for groups of 4. So here's a group of 4, so I'm going to bring a 3 out. Here's another group of 4, so I'm going to bring another 3 out, and then kind of squeeze at the end is another group of 4. And there's nothing left, so I actually don't need that radical. And then we just have to multiply 3 times 3 times 3, which is 27. And that is our final answer. All right, let's try another, maybe just a little bit more difficult. So we have the square root of 2x plus 8 minus 4 equals 6. So again, we want to isolate whatever is underneath the radical first. So start by adding 4 to both sides. Okay, now that we have our radical isolated, we need to undo the radical. And when our index isn't written, it is a 2. So that means if I raise this to the 2nd power, it should undo the radical, but I have to make sure to raise the other side to the 2nd power. So I'm left with 2x plus 8 equals 100. Subtract 8. 2x equals 92. And if you divide both sides by 2, x will equal 46. So there you go. Not too bad, but let's talk about what happens when we have two radicals in the same equation. Now here, like I said at the beginning, our goal is to isolate the radicals, is to isolate the powers, but here I have two radicals and I can't combine them. So what we want to do here, a little trick, is to get the radicals on opposite sides of each other this time. So we're going to add 3 times the square root of 2x to both sides. And I'll show you why here in the next step. So 4x plus 28 equals 3 times the square root of 2x. Now that we have our radicals on opposite sides, what we can do here is raise both sides to the second power, because all I care about is getting rid of the radicals, and everything else is just kind of the after effect of doing that. So on the left side, pretty easily, the exponent cancels the radical and leaves me with 4x plus 28. On the right side, you got to remember to take your power to a power rule. So we actually have to take 3 to the second power, which is 9. And then I have to take the square root of 2x to the second power, so that's where it undoes the radical. So we have 9 times 2x, which is just 18x. Okay, so don't forget to square any outside numbers if you happen to find yourself in this situation out in the wild, which is very possible. So we have 4x plus 28 equals 18x. So now it's just kind of a linear problem, some basic Algebra 1 stuff here. So 28 equals 14x. And if you divide both sides by 14, you get x equals 2. So again, if you have two radicals, you want to move them to opposite sides. And then, so it worked the same if my index was 3. On both of these, I want to move them to opposite sides, but in this case, I would raise it to the third power instead. I don't know if I would add that if I were you. I just don't want to confuse you, but just to know that you can do it with any radical. Just move them to opposite sides and then take the respective power to undo the radicals. All right. So here we have probably the most difficult type of problem because it's going to involve quadratics when it's all said and done. So we only have one radical, so our goal is to isolate the radical. Well, here it is. So now we need to think about how we're going to undo it. My index here is 2, so I need to raise this to the second power, but I also need to raise the entire other side, the left side, to the second power as well. Okay, so the right side is pretty easy, 2x plus 28. The radical is undone by the exponent, nothing tricky there. But the right side, what that means is I have 2 x plus 2's, and then you're going to have to FOIL these out. So x times x is x squared, x times 2 is 2x, and then we're taking 2 times x, and we get another 2x, and 2 times 2, which is 4. So you FOIL it out, and then you combine some like terms. Okay, so we have x squared plus 4x plus 4 equals 2x plus 28, because I can combine 2x and 2x. Now we're going to want to move everything to one side here, so we can either use the quadratic formula, factor, complete the square. Those are going to be your 3 options. So let's go ahead and subtract 2x and subtract 28. And that's going to leave me with x squared plus 2x minus 24 equals 0. So normally when this happens, not always, but we try to be nice. We try to make sure that the quadratic you're left with is a nice quadratic that can be factored. So that's what I would try first. And in this case, it can be factored. So let's take a look. So we're looking for 2 numbers. First of all, that multiply to negative 24, but add up to positive 2. So you can list out all the factors if you want, negative 1, 24, and so on, negative 2 and 12. But we want a positive 2 when it's all said and done. So I'm just going to jump all the way down to how about negative 4 and a positive 6. If I multiply, I get negative 24. If I add, I get positive 2. Now, because my a value is 1, I can factor quickly by saying x minus 4 times x plus 6 equals 0. And then you need to solve each one of these. So x minus 4, set it equal to 0, and x plus 6, set it equal to 0. So you get x equals 4, x equals negative 6. So those would be our answers. We're going to have to go back here. So example number 5 is no different than what we've done. But when you jump all the way back up to the top here, we're going to talk about this word extraneous now. We've talked about it before, but it's like it's a solution that you can get, but you actually can't get. So what's going to give you an extraneous solution? So for example, if you take any even index radical, so any 2, 4, 6, 8, 10, any index that's even, the number underneath that radical has to be positive. So in this first example, I have the fourth root, the fourth root of x. So that means that when I solve this, x has to be greater than or equal to 0. I cannot get any negative numbers here, but you'll see my answer is 625, so that answer is a good answer. In this case, we have, if you were to rewrite this, this would be 3, this part right here, sorry. This would be 3 and then the third root of x to the fourth. When your index is odd, nothing to worry about. You can take the odd root of any number. Negative, positive, doesn't matter. So you have nothing to worry about here as far as extraneous solutions are concerned. In example number 2, what in the world? My apologies. Jump all the way back down to, there we go. In example number 2, we have a radical square root here. So we cannot have a negative number. So what you need to do is make sure that 2x plus 8 is greater than or equal to 0. It can't be less than 0 because that's going to give me a negative number that we're taking the square root of, and then you introduce imaginary numbers, which, even though we've talked about them, we're trying to avoid. So if you subtract 8, 2x is greater than or equal to negative 8, divided by 2, that means x has to be greater than or equal to negative 4. So if you look at my answer, 46 is greater than negative 4, so my answer is good. In the next one, kind of the same thing here. We have square roots. We have the square root of 4x plus 28 and the square root of 2x. So what has to be true is that 4x plus 28 has to be greater than or equal to 0 because we cannot have 0 underneath that radical even index. Subtract by 28, 4x is greater than or equal to negative 28, and if you divide both sides by 4, you get x has to be greater than or equal to negative 7. And if you take this radical over here, 2x has to be greater than or equal to 0. Goodness, it's a terrible greater than symbol. Divide both sides by 2, x has to be greater than or equal to 0. So, greater than or equal to 7, greater than or equal to 0. This one over here kind of cancels out that one because 0 is bigger than negative 7. So 2 is bigger than 0, so we were good to go here. No extraneous solutions yet. But let's take a look at what spurred this conversation. So we have another square root. So 2x plus 28 has to be greater than or equal to 0. So if you subtract 28 from both sides, 2x is greater than or equal to negative 28. Divide both sides by 2, x has to be greater than or equal to negative 14. Okay, now we have two answers here. If you check the first one, x is greater than, or x equals 4, that's greater than negative 14. If you plug in the second one, negative 6 is also greater than or equal to negative 14, so these are actually both good to go. Okay, so just make sure you're checking for those extraneous solutions. So just one more here. The square root of 6x minus 5 plus 10 equals 3. So again, the goal is to isolate the radical. So square root of x plus 6x minus 5. If I subtract 10, I get equals negative 7. So this is kind of what is a little bit tricky here. So if you think about this logically, we just said in all these examples, you need to make sure that your radical is not a negative number, because we can't take the square root of a negative number. But also, can you take the square root of any number and get any negative number back? Is there any number you can think of? And hopefully you're sitting there telling me no, you can't take the square root of a number and get a negative number back. It just doesn't work like that. So that means in this case right here, no matter what I do on the left side, oh my goodness. No matter what I do on the left side here, I can't plug any values in and get this negative 7 out. It's just not going to be possible. So therefore, this would be, well, I guess we're going with the highlighter. No solution. All right, and so this is day 1 again. Just a reminder, you can see that we will continue this the next day. So don't worry too much if you don't completely understand what's going on, but it can't get any more difficult than what we've done so far. Like this problem right here, put a little star by it. This is as tough as it's going to get. So make sure you understand what was happening here, and then we'll try again.